So today we're going to talk about the Edgenuity section 6.3, the rational roots theorem. There are two objectives. To this section. The first is to determine roots of and factors of a polynomial function, and to factor a polynomial function. Excuse me. And to use the rational root theorem to determine possible roots of a polynomial function. And so we're going to talk about finding the possible roots first, okay? And here's the way that you do this. The polynomial needs to be in standard form first. In other words, you got to have the degree defining term, the largest power term, first, and then you got to go down by powers, and the number should be last. And what the rational root theorem says is if you take all the factors of this divided by all the factors of that, then you have all the possible rational roots, okay? So 4 factors into, let's not do it that way. 4 is 2 times 2, but it's also 4 times 1, and we only need the 2 once. So that's the numbers that we can use with 4. 3 only has 2 factors, 3 and 1. The only way you can make 3 is by doing 3 times 1, without getting into weird combinations, fractions and roots and stuff like that. So what we're going to do is the possible rational roots are the following. You do plus or minus, meaning you can use the positive of this or the negative of this, and then you take every combination. So you start with 2 and divide it by each one of those. Okay? So plus or minus 2 over 3. Plus or minus 2 over 1. Okay? Then I'm going to do the same thing with 4. Plus or minus 4 over 3. Plus or minus 4 over 1. And then finally I'll do it with 1. Plus or minus 1 over 3 plus or minus 1 over 1. And then I'll just clean those up a little bit and call it plus or minus 2 over 3 plus or minus 2 over 1 is 2 plus or minus 4 over 3 plus or minus 4 over 1, which is just 4, plus or minus 1 over 3, and plus or minus 1 over 1, which is just 1. And then you might put them in order. That part really doesn't matter. As long as you're doing the last factors over the first factors. Okay? The last factors over the first factors, and putting plus or minus in front of each one. And then the idea is all of these are not going to work, only some of them are. And then you have to have ways of testing them, and we'll talk about that in the future. So this right here is the entire list of possible roots, possible rational roots. This doesn't include roots with like square roots in them, things of that nature. Okay? I'll pause a moment for questions. Okay, and let's move on to the next board. Another one where we're going to find the potential roots. Now this one's going to be a little bit easier because look, we don't have anything there, which means there's an understood 1 there, and that's going to be really nice because 1 only has one factor, right? 1. It's the only way you can make 1 is 1 times 1. So let's take the factors of 9. 9 times 1 is 9. 3 times 3 is 9. I only have to write down the 3 once. And I think that's it. Usually when I do these, let me back up for a second. Usually when I get the factors, I go, okay, 1 times 9 is 9. Is 2 times anything 9? No, so I'll skip 2. Is 3 times anything 9? 3 times 3 is 9, so I only need 3 once. Is 4 times anything 9? No. Is 5 times anything 9? No. 6? No. 7? No. 8? No. And 9 times 1. So once I finally loop myself, get back to the beginning, then I don't have to check anymore. Or once I start repeating numbers. And so really I could have stopped at 3 because I technically repeated 3. Right? And then 1 is 1 times 1, so that's the only factor there. So I just have to do all of these numbers plus or minus and over 1. So the possibilities are the following. Plus or minus 1 over 1, which is 1. Plus or minus 9 over 1, which is 9. Plus or minus 3 over 1, which is 3. And that's it. Now, the fundamental theorem of algebra tells you that there can only be 4 roots. You can only have as many roots, as many solutions, as many x-intercepts, at most as the degree of the polynomial. You could have less because you could have some repeating ones, you could have some imaginary ones, but you can't have more. So I've got 6 possibilities here, so I'm definitely they're not all going to work. How do I know which ones will work? Well, there's actually a pretty straightforward way. It's not always a quick way, but it is a straightforward way. You plug each of those numbers in for x, and you simplify and see if you come out with 0. And that'll tell you which ones are actually roots. Okay? But we'll talk about that again a little bit later. Questions. I will pause for questions. Okay. There being no questions, let's move on to the next slide and get into a bigger problem. Okay? So let's talk about how you would actually factor a big thing like this. Now, I'm giving you the graph with it, and the reason I'm giving you the graph with it is because when we factor, what we're looking for are the roots. And the roots are the x values for the x-intercepts. So there are 2 x-intercepts clearly defined here that we can at least test. Now, you always need to test these x-intercepts because it looks like it's an x-intercept at -1 at x equals -1, but the fact is that it could be -1.00000001. And you'd never know that by looking at it. So you do have to test it. And again, the most straightforward way to test it, there are actually 2 ways of testing it, but the most straightforward way of testing it is plug it in and see if you get an answer of 0. Because if you plug in the x and calculate, you're going to get the y value, and the y value for every x-intercept is 0. So if I plug in -1 for x, and I get out 0, then I know the y value on the graph has to be 0, and that makes it an x-intercept, which makes it a root. So let me calculate f of -1. Well, that's 4 times -1 to the 4th minus 8 times -1 to the 3rd. And I'm going to say, instead of minus, I'm going to say plus negative every time there's a minus. So it says minus 3 times -1 squared, but I'm going to say plus -3 plus 7x minus 2, oh, not x, but 7 times -1 minus 2, or plus -2. And then I'm going to figure out what the answer is. Well, -1 to the 4th is -1 times -1 times -1 times -1. So 2 pairs of -1 times -1 gives me a +1 times a +1. So this is 4 times 1, which is 4. If you need to see that, please let me know. Plus -8 times, and then -1 to the 3rd is -1 times -1, which is +1, times 1 more -1, which is -1. So -8 times -1 becomes +8. Plus -3 times +1, -1 squared is -1 times -1, which is +1. So -3 times +1 is -3, plus 7 times -1, which is -7, plus -2. So if you look, these three give me -12. That is -10 plus -2 is -12. And these two give me +12. So I've got 12 plus -12, which indeed is 0. So x equals -1 is a solution, or root. Okay? So that is super helpful, because then that means, this is the trick, this is one of the clever tricks, to get the factor out of that. All I have to do is solve it so that it's equal to 0. In other words, add 1 to both sides, and then x plus 1 equals 0, so x plus 1 is a factor. Okay, so that's an important thing there. X plus 1 is a factor. Now, it's possible that 2 is also a root. However, here's what I'm going to say about finding more than one root this way. It's really easy to put in -1. It is much harder to put in 2, right? Because then you have to figure out what's 2 to the 4th, 2 to the 3rd. The numbers start getting real big real fast. You have to do 2 to the 4th, then times 4, and you have to do 2 to the 3rd, then times 8. And so you start getting these pretty big, unwieldy numbers right away, and you're only checking. So the other way to do it is say, I already have one factor, and I am going to divide this by that one factor. And I probably should have given myself more room, but we'll take care of that in a moment. So actually, I'm going to erase this stuff, unless there's a question. Let me know if there's a question. Because I'm going to erase this and only leave the fact that x plus 1 is a factor. And then I'm going to go through and divide this large polynomial by x plus 1. That's how I'm going to start getting the rest of the factors. Okay? So I don't see any questions, so I'm going to erase this. And we're just going to take that polynomial at the top, and we're going to divide it by that factor, x plus 1, that we figured out. So we're going to do 4x to the 4th minus or plus negative 8x cubed plus negative 3x squared plus 7x plus negative 2 divided by, I hope I left myself enough room there, x plus 1. Okay, so there is my long division, and the way you do long division is you look at the first term that you've got, and you ask yourself, what do I have to multiply by the first term here, which is x? What do I have to multiply x by to make this, in this case? Well, 4x cubed times x would give me 4x to the 4th. So I'm going to put a 4x cubed up here. And in long division, what you then do is you take this and you multiply it by all of that, which is going to require us to distribute. And then you put it underneath this stuff here. So 4x cubed times x is 4x to the 4th, and that was the whole point, was to make those two the same, plus 4x cubed times 1 is 4x cubed. And then in long division, then you subtract these two things right here. And in order to subtract them, what you have to do is distribute a negative to the bottom part. And so I'm going to change the signs on both of them, and that's going to be me subtracting. That's me distributing a negative. So this becomes negative, and that becomes negative. So I've changed the signs on both of them. So I hope you can see that pretty clearly by the change of color. Then you go through and add them. Now these two will always cancel. If those two don't cancel, you didn't set it up right. Okay? And then you got to figure out those two. So we've got negative 8x cubed plus negative 4x cubed. That sounds to me like negative 12x cubed. Then in long division, you always bring down the next thing, and this is no different. So it's plus negative 3x squared. Then you go back up to the top here. You put a plus, and you start this process all over again. Okay? So now I need to multiply by x to make negative 12x cubed. Well, that means I have to multiply by negative 12x squared, because negative 12x squared times another x gives me negative 12x cubed. That is 3 of them. Plus negative 12x squared times 1 is negative 12x squared. Then I need to subtract them, so in order to do that I have to change the signs. So that becomes positive, that becomes positive. These two cancel, they better cancel. That's how I designed it, so that they would cancel. And then negative 3x squared plus 12x squared looks to me like positive 9x squared plus, bring down the plus 7x, put a plus up here, and start the game over again. What do I have to multiply by x to make 9x squared? I keep saying multiply by x because x is the first thing in this, that x right there. So it's the first term of that, whatever that is. Okay? Oops, I lost part of my plus. So now 9x times x will give me 9x squared. So I'm going to put a 9x up here and do 9x times x is 9x squared plus 9x times 1 is 9x. I need to change the signs so that I am subtracting. Those two cancel. They better cancel. That's how I designed it. And then 7x plus negative 9x is negative 2x. And bring down the plus negative 2. And now the question is, how do I make this? So I need to multiply by x to make negative 2x, put a plus here, and then negative 2 times x is negative 2x. So negative 2 times x is negative 2x, plus negative 2 times 1 is negative 2. And now, when I change the signs on those, you'll see that actually everything cancels. Those cancel because you designed it that way, and these make 0, or cancel, however you want to think of it, for a remainder of 0. Okay? That's the other way that you can check. You can plug in and check for 0, or you can do the long division, and if you get a remainder of 0, then you know it's a factor. So there's two ways to check, and sometimes one is better than the other. Sometimes one is easier than the other. Okay? So what that tells us, and I'm going to put that kind of over here, is that if I did x plus 1 times this big long thing here, see if I can squeeze it in, 4x cubed plus negative 12x squared plus 9x plus negative 2, if I multiplied those two together using distribution, I would get that right there. That's why they're factors. Okay? Before I'm going to erase this particular piece of long division because I have to do it again. Are there any questions before I erase this piece of long division? I'll give you a chance to really look at it good. Okay, if there are no questions, I'm going to erase this long division problem, and we're going to go on to the next step that is required here. So I'm going to get rid of this long division problem, and we're going to do another long division problem. So don't worry if you haven't figured out long division the first time through. We're going to keep doing it. Okay, so here we go. All right, so erasing all this long division, because now what we have to do is now we have to deal with the new guy, the slightly smaller one. So now we know that x plus 1 times this slightly smaller but still pretty long thing, which I'm going to copy down one more time, that thing is another factor. And now if we can find another factor, then we'll be good. Okay? Now this one is a little bit easier to plug 2 into. I'm going to plug 2 into this and check for 0. And there's a little less work to do. Oh, and I messed up there. I put cubed instead of squared. Sorry about that. This is a little tiny bit easier to plug 2 into, so I'm going to kind of plug 2 in and calculate real quick to see, because if 2 is a factor of this, or is a root of this, then it has to be a root of this, because I haven't used it yet. Sometimes the roots repeat, but if you haven't used one yet, that's sort of your better bet, okay? So 2 cubed is 8, 8 times 4 is 32. 2 squared is 4, 4 times negative 12 is negative 48. 9 times 2 is 18, and then negative 2 here. So these two make negative 50, and these two make 50. So yes, indeed, 2 works. I hope everybody saw that. So we know that x equals 2 is a root, or a solution, sometimes called also. Then that means that if I solve it for 0, x minus 2 is a factor. And now I can do the long division with x minus 2 with this shorter one. And so to be a shorter long division problem. So let's do that long division problem. So we know we're going to have x minus 2. Also, I'm going to write that off to the side so I can erase this stuff. So I have room for the long division. And remember, I'm recording this so you can go back and look at even the things that I have erased. Okay? So we're going to be dividing by x minus 2, and we're going to do 4x cubed plus negative 12x squared plus 9x plus negative 2 divided by x minus 2. Or let's even be more careful and call it x plus negative 2. So the question is, what do I have to multiply by this to make that? Okay, what do I have to multiply by the x to make the 4x cubed? Okay, so, and if you think about it, the answer is 4x squared, right? So I'll put 4x squared up here. Notice that I'm putting the terms above their matching terms. I'm putting the x squareds above the x squareds. Not everybody does that, but I do that. It helps keep me a little more organized. Then I got to take this and distribute it to both of those and put that underneath. So 4x squared times x is 4x cubed plus 4x squared times negative 2 is negative 8x squared. Then I need to subtract them. In order to subtract them, I have to distribute a negative, so change the sign. Then those two cancel. They better cancel. That's how you design it, so that they will cancel. And then negative 12x squared plus 8x squared, positive 8x squared, is negative 4x squared. And bring down the plus 9x. and then put a plus up here and start over. What are you going to multiply by this to make that? And now the answer is negative 4x. Negative 4x. Now you got to distribute that negative 4x. Negative 4x times x is negative 4x squared plus negative 4x times negative 2 is positive 8x, because a negative times a negative is positive. Then I need to subtract them. I need to change the signs to do that because I need to distribute a negative. So change the sign, change the sign. These two cancel. They better cancel. That's how you designed it. And then 9x plus negative 8x is 1x, or just x. And we'll bring down the plus negative 2, put a plus up here, and start the game over. What do I got to multiply by this to make this? And the answer is 1. 1 times x equals x. So we'll put a 1 there, and 1 times x equals x, plus 1 times negative 2 equals negative 2. We'll change the signs so that we're subtracting. Those two cancel, and these two make 0, which we already knew because we knew that 2 was a root, so x minus 2 had to be a factor, and the whole point was to get this, right? So now, here's what we know now. Now we know that we've broken it down even more, and I'll write it here. Now we know that x plus 1 times x minus 2 times that answer, 4x squared plus negative 4x plus 1, is how this breaks down one step further. Okay? And the nice thing is that once you have it in squared form, you can set it equal to 0, complete the square, get your two answers, solve them each for 0, and that gives you your other two factors. So we'll do that in a moment. I'll let you look at the long division again. Let me know if there are any questions. Okay, there being no questions, I'm going to erase the long division, and we're going to talk about this last thing. So here we go. So now we have broken down that not only does this equal these two things multiplied together, but now it also equals these three things multiplied together. So I'll write them. One more time. And now if I could just break this down, I'd be all set. So the first thing I'd like to do is see if I can just factor it into two pieces. Right? Can I look at it and factor it? Well, that is, well, let's see. Let's see if there's a minus or a negative there, and there's a plus there. If there's a plus there, the pluses and minuses in between here are both the same, and they're both that sign. So it's minus and minus. Then I need factors of this here and here. Well, that's nice and convenient because the only factors of 1 are 1 and 1. Then I would need the combination of these two and these two multiplied together and having this done to it, that adding, that is, to make that number there. So I think if I do 2x and 2x, that happens, right? I get 2x plus another 2x makes, or actually negative 2x and another negative 2x does indeed make negative 4x. So it factors. That's really nice. Now, if you didn't know that, here's the other way you would have done it. You would have said, let's do 4x squared plus negative 4x plus 1 equals 0. And let's solve that. And we'll solve that by completing the square. In order to set it up to complete the square, I need to factor a 4 to the front and get rid of it. Before I do that, I'm going to move the constant to the other side. So that's 4x squared plus negative 4x equals negative 1. Then I'm going to factor a 4 to the front, and I'll have x squared plus negative x. And the whole thing will equal negative 1. I'll divide by 4, and that will give me x squared plus negative x equals negative 1/4. Then in order to complete the square, I need to do some side work there. I need to take the coefficient there, just the number, which is 1. I need to take half of it. So half of 1 is 1/2. And I need to square that, which will be, I'll deal with what that is squared later, but I need to add and subtract that on this side. So then I'll have x squared plus negative x plus 1/2 squared minus 1/2 squared equals negative 1/4. Now the reason I'm doing that is because this is my completed square. And it will look like this. X, and then this, so x minus this number, 1/2, all squared. So if you did that problem, if you set it up as x minus 1/2 times x minus 1/2, you would come up with that. Okay? Then minus 1/2 squared, and 1/2 squared is 1 squared over 2 squared. So it's minus 1/4 equals negative 1/4. And then you would add 1/4 to both sides, and that would be really convenient because you'd get 0. And so ultimately you would get x minus 1/2 squared equals 0. And you could solve that pretty easily. But as you can see, that takes a whole lot more work than just factoring it here. Whoops. Go over to the pen. Than just factoring it there. So I showed you that, but I'm not going to leave it up on the screen because it's really messy and it's not necessarily helpful this time. So instead, we're just going to leave the factoring because the factoring was a whole lot quicker, a whole lot easier, right? And so what we can now see is that the factors are x plus 1, x minus 2, times 2x minus 1 times 2x minus 1 again, which I can call 2x minus 1 squared. So this is the fully factored form of that. Now that was a lot of work, but it was a whole bunch of smaller problems. And the main tools that we used, you potentially use 3 of 4 main tools, I guess, or 2 of 3 main tools, depending on how you think of it. Plugging in and checking was sort of one main tool. Long division was definitely a main tool. And then once you got it down to the squared, to having a factor that's just squared, you can try factoring it, or you can set it equal to 0 and solve it, and then you would have to, whoops, I forgot. No, I didn't. No, I didn't. Never mind. And then you can solve it equal to 0 and come up with the factors. So that is the factoring of it. We've only got one more problem, so stick with me, guys. Last problem. Let's solve this. Okay? So how are we going to solve this? Well, we're going to set it up as a polynomial, get all the factors, and we're going to be really clever about that. So here's how we're going to solve it. We're going to set it so that it's equal to 0 first by adding 20 to both sides. And what we're going to have is x cubed minus 21x plus 20 equals 0. And that's how we're going to solve this. Okay? And I'm going to use the rational root theorem. I'm going to take the factors of this divided by the factors of this. Remember, there's an understood 1 there. So factors of 20 are 1 times 20, 2 times 10, no 3, 4 times 5, and then we're back to 5. So we've got all the factors there. Factors of 1 are just 1, so that's nice. So possible factors are plus or minus 1 over 1, plus or minus 20 over 1, which is just 20, plus or minus 2 over 1, or just 2, plus or minus 10 over 1, plus or minus 4 over 1, plus or minus 5 over 1. And then I'm going to plug the easy ones in and see if I get 0. Okay? So let's try 1 first, just in case it works. So if I plug in positive 1, that'll be 1 minus 21 times 1, which is minus 21, plus 20, which is positive 1 plus positive 20 is 21, and 21 plus negative 21 is 0. So positive 1 works. And that's awesome, because if positive 1 works, then I'm essentially done. Okay? Now there's another way to get a good guess, and that is to set this up as a polynomial function, graph it with technology like, say, Desmos.com. That's Desmos.com. And look at the x-intercepts and look at the x values and see if you get x values that you can try. Okay? So that's another way. Because roots are just x-intercepts. They're the x values of the x-intercepts. But since I know that x equals 1 is a solution, is a root, then I can solve that one for 0 and know that x minus 1 is a factor. And then I can do the long division on it. So let me erase that stuff, that checking. And I'll do the long division. And I'll have to do it x cubed plus, notice there's no x squared term, and the way you have to handle that with long division is you need to put it in as a placeholder. So plus 0x squared minus 21x, or plus negative 21x, plus 20 divided by x minus 1. Now, because I know it came out to 0 when I plugged in 1, I know that I'm going to get a remainder of 0 on this. So what do I multiply by this to make this? X squared. See, that's why I needed that x squared placeholder. So then do the multiplication. X squared times x is x to the third, plus negative 1, so plus x squared times negative 1 is negative x squared. Change the signs so that I am subtracting. And those two cancel. They better cancel. That's how you designed it. And 0x squared plus x squared is x squared. Bring down the plus negative 21x and start over. Put a plus up here and start the game over. What do I have to multiply this to make that? Well, x times x is x squared. So now distribute this x. X times x is x squared, plus x times negative 1 is negative x. Change the signs. Distribute a negative 1, which changes the signs so that I am subtracting. These two cancel. They better cancel. That's how you designed it. And then negative 21x plus x is negative 20x. And bring down the plus 20, put a plus up here, and start the game over again. So now, what do I have to multiply by this to make that? And the answer is negative 20. So negative 20 times x is negative 20x, plus negative 20 times negative 1 is positive 20. And when you subtract them, they both cancel, leaving you with a remainder of 0. So now I know that x minus 1 times x squared plus x plus negative 20 is the same as x cubed minus 21x plus 20. And so the last thing I have to do, I'll pause for a moment and let you look at the long division and give you one more chance to ask questions about the long division. Take one more look at the long division, see if there are any questions. Okay, there being no questions, I'm going to erase the long division and do the final part of this problem. So the last part of this problem is to set those two factors equal to 0 and solve. So here's what we've got now. We've now got that x minus 1 times x squared plus x plus negative 20 equals 0. Now, if it would be nice if I could break down this into two factors. An x squared here means I can start with x and x. A minus or negative here means one of them is plus, one of them is plus, one of them is minus. And then you need factors of this number that do this to make the number here, which is a 1. So I need two numbers that multiply to make 20 and subtract to make 1. And those numbers are 4 and 5. 5 times 4 is 20. 5 minus 4 is 1. And then the larger number goes with that sign, this sign right here. So the 5 goes there and the 4 goes there. So that makes it really nice because then I've got x minus 1. That's terrible looking. I've got x minus 1 times x plus 5 times x minus 4 equals 0. And what's really nice about this is I've got three things that multiply together and make 0, meaning at least one of them has to be 0. And I don't know which one, so I just account for all cases. This is called the zero product property, you might remember. And so you just take each individual one and solve them equal to 0. So set all of them equal to 0 and solve them all separately. You would add 1 here, get x equals 1. You would subtract 5 here, get x equals -5. And you would add 4 here and get x equals 4. So if I write them in order from left to right on the number line, I have that x equals -5, 1, and 4. And that is the three solutions that work. So if you plug in all three of those for x, any one of those for x, you'll come out with a true statement there at the top. Okay? I will pause again to see if there are questions, but that is the last problem for today, so thank you very much.